Here we are going to multiply. Anytime you have a whole number, don't forget there's an invisible 1 underneath. You're going to multiply the numerators together. So 24 times 1 is 24. And 1 times 6 is 6. Then we're going to figure out if 24 can be split into 6 equal groups. And it can, because 6 times 4 is 24. So 4 is our answer there. If it does not come out to a whole number, you can leave it as an improper fraction or as a mixed number. It's up to you. But if it does come out to a whole number, you'll want to change it. This is a digital lesson, so if you do not have it open or available to you, just follow along in the video and take notes in your workbook. Here it says to adjust the rectangle so that it has an area of 12 square units. So you can see in here right now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and we want 12. So now I have 4, 8, 12 squares inside of my rectangle. Try to make a parallelogram that has an area of 12 square units. Well, a rectangle is a parallelogram. So if I make a rectangle, that would be 3, 6, 9, 12. It says, excellent. Challenge yourself and make one that is not a rectangle. So let's see, if I were just like tilted this over or pushed it to the side, would that also be 12? It shows that they chopped off a piece of it. Let's try that again. They cut off this little triangle part and moved it to the other side. So now there's 3, 6, 9, 12. Explain how you know that it has an area of 12 square units. It had a height of 4 and a base of 3. So 3 times 4 does equal 12. We could also rearrange. To show that it is the same as a rectangle. Try to make a triangle that has an area of 12 square units. So let's see, we needed a base of a 4 by 3 to get a rectangle that worked. Does that work in a triangle? No. That does not give me an area of 12. That gives me an area of 4, maybe 5, 6 if I were to combine those. Okay, let's try something different. What if I made it wider? Now I have 1, 2, 3, 4, 5, 6, and then these are all halves, so that looks like 9. Let's see if I made it taller. Now that's too much. I have 3, 6, 9, 12, 15, 18. So I have a 6 by 6. That gave me 18. What if I tried a 6 by 4? Yeah, so now I have 2, 4, 6, 8, 10, 12. So it says, explain how you know that it has an area of 12 square units. When we cut up the triangle and rearranged it, we created a rectangle that was 6 wide and 2 tall. And 6 times 2 equals 12. So that was a 6 wide and 4 tall triangle. What about this figure? How can you try to find its area? We could try to cut up the parts and rearrange the shape to approximate how many squares it would fill in. But it does have this curve, so there's going to be a part that doesn't quite make up a perfect square. In the last one, all my sides were straight, but here I have a curve. What about this figure? How can you try and find its area? We could try to break it into a triangle and then cut up these parts to fit into the little missing sections. Okay, this one's looking even more challenging. We could start by creating a grid system and counting the squares that are inside of it. Then we would piece together the partial squares to form whole squares and count those. So you can see here in slide 7, they've created that grid system. So it says click on the squares to shade them. Use this tool to estimate the area of the figure. So I see a full square here, 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 here. All of these squares are complete. And then I see some partial squares here as well. So I might combine these 3 and count it as 1. Then here, if I combined this piece and this piece together, see, I'm going to take this chunk and this chunk. So I'm not going to use this one, but I am using this one. And I've already addressed this gap is down here, and that gap is down there. Then I can combine maybe these 3, one here, and one here to create another one. So I've got this one and this one taken care of, but I'm only going to shade in 1 extra square. Then this one looks like a complete square here. This one looks like about half of a square. And here's another one that's about half of a square. So if I combine this piece and this piece together, that could create one. And I'll check off that I've already taken that one into consideration. This square right next to it is almost a full square, and here's a little piece, so I'm going to count this one, and I'm going to scribble out that I don't need this piece because I already took care of it by shading it in here. Then this and this look like they could combine to make a square, so I'm going to shade that one and mark off that I've taken that one into consideration. This one looks like almost a full square. This one is almost a full square and it needs a little bit extra, so I'm going to mark this one and check off that I used this little extra part here. This one looks like almost a full square. Here this looks like if I combined these two and these two together, I would get 2 full squares. So I'm going to mark these, and I'm going to scribble out that I used this part. This part is about half, and this part is about half, so I'll mark off that I'm putting this piece down here with this one. This piece is almost a full square, and then this piece is just a little chunk, so I can combine these two to create a full square. This one needs a little chunk, and there's a little chunk here I could use. So I'm going to mark off that I used this one and that piece to form a square. Then this piece needs a little chunk, so here's a piece here I could use. So I'm going to mark off, okay, let's put this piece with this one, and this piece with that little part. And then I've got a little part here that still needs to be counted. So I'm just going to add one extra section here for this one. So it is about 49 square units. Click on the squares to shade them in. Try to get as close as you can to the area of the circle to the area of the circle as you can. So attempt 1, I'm going to shade in. Here's the 4 completed. If I combine this piece and that piece together, that would work. Oh, I don't want to. Okay, so shading these in. The shaded area that I have here, or the complete parts, is 4 square units. And then the partial areas, this would be about 1, 2, 3, 4. And then I could combine these sections to create another one, so maybe about 5 additional for a total of 9 square units. Then we can change this to shrink our squares. Now keep in mind when we have a half by a half square, a half times a half is a quarter. So each of these is a quarter of a square unit, because it takes 4 of them to create a whole square from the last section. Okay, so I have 24 whole units, but I need a quarter of that. 24 split into 4 parts is 6. Then we're going to work on combining the partial pieces. Let's see here. If I combine this piece with this little part, that makes 1. This piece with this little part makes 2. I might be able to combine 1, 2, 3 of those to make another one. Here I've got 1, 2, 3 sections to create another one. This I can combine this piece and this piece to create one. And I could do this piece with this little piece to create one. Woo. Then I could use this piece and this little part to create another full piece. This part and this part look to be about another section. Here I have a medium and then a little small. So if I were to keep going, creating pieces that I could combine, let's see, I have green, yellow, the light blue, pink, dark blue. So if I was counting up all of my partials here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 partial pieces, but remember they're a quarter. So 12 split into 4 parts is 3, and 6 plus 3 is still about 9. Let's break them down even further. So we're going to fill in all of the pieces that are full squares. And these are a quarter wide. So a quarter times a quarter is 1/16. So whatever amount we have here, we need to split into 16 parts. So we have 120 squares. And if we split that into 16 parts, that would be 7.5 square units. So we're going to put that in here. And then we need to create our shaded sections for the partial pieces. So I'm going to combine some pieces here. So we'll combine like these two, make one square. These two would make a square. These pieces could combine to make a square. And so we're going to go through and we're going to count them up. And then we'll divide however many partial squares we get by 16, because remember they're a 16th for the area. Now after counting, I got about 27 partial squares if I were to combine all my pieces. And then I split it into 16 parts, which gave me a funky decimal of 1.6875. So I'm just going to round that up to about 1.7. And so 7.5 plus 1.7 is about 9.2. This one says, move the circle around. What do you notice and what do you wonder? So as I move my circle around, I'm able to capture more whole squares or a different setup of the whole number of squares inside, depending on how my circle is placed. What do you wonder? Is there a way where I could place it that's ideal? It says, what is different this time? How might this relate to the area of the circle? Well, this one includes the partial squares filled in as well. How might this relate to the area of the circle? This will over-approximate the area because we have additional space outside of the circle. Dylan created these polygons. How can Dylan use the areas of these polygons to estimate the area of the circle? Well, in this one, I see 1, 2, 3, 4, 5 shaded squares. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So Dylan should know that it has to be between 5 and 18. Knowing that the area of the circle is between the areas of these two polygons, how could you improve your estimate of the area of the circle? We could move the circle to a different location on the grid, or we could make our squares even smaller. Like we saw when we shrunk the size to a quarter, we were able to get an estimate that might be closer to our actual area of the circle. So this one says, here, if we move it, let's see, the area that has to be greater than 5. And then if we move on to the dotted, has to be less than, okay, so we want to minimize this. I think the lowest number I saw was 15. So our estimate, somewhere between 5 and 15. Well, you might just go in the middle. You might say, well, maybe it's closer to 15 or closer to 5. Now we're going to change our unit to a half of a unit. For the shaded squares, that's going to be the area that has to be bigger than. So it's 6.5. We're going to try and maximize this measurement. So if you see anything bigger than 6.5, we want to go for that. And then for this next one, we want to use the dotted squares, and we want to minimize this amount. So the smallest number is what we're going to want to keep. You see 11.25. Okay, so somewhere between 11.25 and 6.5. So 10 is still a reasonable estimate because it's still in between. So you could estimate that the area is still 10 again. This time I think it's going to be smaller because I was able to shrink this by quite a bit. And this one grew only by a little. So I'm thinking maybe it's closer to 9. And now we're going to make our pieces even smaller. Starting with the shaded, it's going to fill in this. We want to maximize that number. 7.5. Okay, that seems to be pretty consistent. And then the dotted, 10.75. Okay, so our estimate somewhere between 10.75 and 7.5. So again, I'm still thinking it's somewhere around 8 or 9, maybe 8.5. And then we're going to submit. Zoom in as far as you can using the buttons. So we're going to see smaller squares. So that's as far as we can go. And it says, give your best estimate of the area of this circle. So this is between 4.76 and 5.8. So we're estimating somewhere in the middle of those two numbers, or just in between. So I'm going to go maybe 5.2. So the way that we are approximating the circle right now is by filling it in with little teeny tiny squares. But we can use a better method to find the area of a circle. And we're going to learn more about how to do that in a future lesson. Just like how we had a formula for finding the area of a rectangle or the area of a triangle. We'll find the formula for the area of a circle in an upcoming lesson. But for now, we're just approximating using really teeny tiny squares because it's square units.